right, so problems 1 through 8, momentum problems. Let's start with number 1. You have to be able to do all 8 plus more, but let's just start with number 1. Understood? A train with a mass of 2.1 times 10 to the 5th times 10 to the 5th kilograms. A train, all right? So mass train equals 2.1 times 10 to the 5th kilograms. Is moving at 12 meters per second. Velocity, 12 meters per second. When the engineer applies the brakes, all right, if the brake force is constant at 3.7 times 10 to the 4th, so the brakes are constant at 3.7 times 10 to the 4th, and that should be newtons. The question will be, I'm guessing that it's time. How long does it take the train to stop? How far does the train travel during this time? Okay, so let's do the time first. Clear? The change in momentum is going to equal the impulse. That's what we've got going on here. The change in momentum occurs when you have a change in velocity because the mass is constant. So m delta t, the impulse is force times time. Clear? The mass is 2.1 times 10 to the 5th kilograms. The change, sorry, what did I say? Delta t, sorry. That's a V. You can correct me, raise your hand, say you made a mistake. Okay, you can do that. Okay. And then, so what's that? It's going to be 12 meters per second, correct? So it's going to go from 12 to 0, correct? All right. So it'll be the mass here times 12 meters per second. What are the unit labels for momentum?
Kilogram meter per second.
Yes, kilogram meters per second. Very good. Excellent. Okay. And so that's going to equal my force, 3.7 times 10 to the 4th newtons. Is that on the screen? Here. I'm here? Okay, good. And then we're going to have T. So what's T going to equal? You need to multiply this and then divide by the force. What do you get? What do you get? Do you realize you're mumbling? Yeah. Rookie?
68.1.
What is it?
68.1.
68.1. What? 68.1
Seconds.
meters?
6 seconds.
Seconds. Okay, good. All right. Is that right? 68.1? Is that what everybody gets? Okay. Okay. So that's the answer. So he's going to apply it for that, right? Yes? So, but what's the distance? What's the distance? How do we get that? Anybody? Nobody. Houston, we have a problem. Excuse, how would you do that? Do it.
Average velocity equals distance over time.
Average velocity equals distance over time. Excellent. All right, can we write it right here? Can we do it right here? Okay, average velocity equals distance over time, correct?
Mm-hmm.
We're solving for what? Distance, right?
Yes.
Okay, so distance is going to equal VT. Can we just say VT, is that okay? Yeah. So what's V? What's V?
6.
What'd you say?
6.
Oh, you're good. 6. Average, right? Remember, average velocity is going to be initial plus final divided by 2. Clear? Okay. So it's going to be 6. Let's leave off the unit labels. Is that okay? And then T is 68. We'll just say 6 times 68 is what?
408. 408.
488?
No, 408.
408.
Yes. Yes.
Is that right? Did we all get that? Is that good? Yes? Where's my cap? Here it is. All right? Yes? We'll do one more and then I'll stop the tape and start another one. Only because it takes so long to upload. So let's just do 2. Let's do all 8. Maybe we'll skip 1 or 2. All right. The next one says, an astronaut with a mass of 81 kilograms. So the astronaut has a mass, these caps. The astronaut, the mass of the astronaut is 81 kilograms. Okay. So it says, an astronaut with a mass of 81 kilograms is outside a space capsule when the tether line breaks. Do you know what a tether line is? It's the line that holds you to the ship. It's just a rope attached to your whatever. Okay. And it breaks. To return to the capsule, the astronaut throws a 4-kilogram wrench away from the capsule, in a direction away from the capsule. I'm the astronaut. My tether broke, the capsule's over there, and I'm going to throw the wrench that way, because I want to go that way. Which one of Newton's laws is most applicable to this example? Yeah, for every action there's an equal and opposite reaction. Excellent. That's really essentially what we're doing here. All right. To return to the capsule, the astronaut throws a 4-kilogram wrench away from the capsule at a speed of 20 meters per second. All right, so the mass of the wrench is 4 kilograms. That is a serious wrench. Okay, and the velocity of the wrench is what? 20 meters per second. Okay? And what speed does the astronaut move toward the capsule? Right? So, what do we do? You have a direction going away from the capsule. You want to call that negative or positive? What do you want to do?
Negative.
We'll call that negative. So this is negative, right? Correct? Now I'm going to be going towards the capsule, and if that's not positive, what did you do? Something really wrong, correct? Yes? Okay, good. So, what do we do? Anybody? Nobody. What do we do? How do we solve the problem? Marie.
So you add the two masses.
All right, wait a second. We have to do this first. We have to say velocity of the astronaut. That's where we're going. And so then what do you have to do?
You add the two masses and you multiply it by the initial velocity.
I'm gonna add these two masses. Is that what you're saying? And then multiply by what?
The initial velocity.
Which is what?
0.
Which is what?
0.
Which is 0. Is that what you're saying?
Yes.
Okay, so we're going to say,
0
so the before is really what you're saying, correct? So we're going to say the mass of the astronaut plus the mass of the wrench, correct, times the velocity of what? They're together, so it'll be the astronaut and the wrench, right? That's the before, right?
Yes.
And then what are we going to say? We're going to say equals or what?
Yeah, equals.
We're going to say equals, okay.
The mass of the astronaut times,
The mass of the astronaut
times the velocity.
times the velocity of the astronaut,
Yes, plus.
okay?
Plus
Plus
the mass of the wrench
the mass of the wrench
times the velocity of the wrench.
times the velocity of the wrench. Are you okay with that?
Yes.
Is that right? Is that okay?
Yes.
And what does the left side of that equation equal? 0. So I can say this is going to equal 0. Is that correct? Yes? So I can say MA VA plus MW VW equals 0. Is that correct? Are you okay with that? Yes? Yes? Okay, good. So, can I erase some of this stuff here? Okay, let me erase this, erase that. So now what?
81.
Now what do I do?
You write the number. 81 times.
So are you suggesting then that the mass of the astronaut times the velocity of the astronaut is going to equal negative the mass of the wrench times the velocity of the wrench? Is that what you're saying? Looks like that's what you have. Is that what you're saying? Yes? So we'll plug in the values that we have?
Yes.
Is that what you want to do? Yes. Okay. So then, what is the mass of the astronaut? 81? Now, you can leave off the unit labels as long as everything is cool. So, meters per second for the velocity, and kilograms for the mass. Is that okay? Yes or no? Yes? Okay. So, and this is going to be times the velocity of the astronaut, which is what? We don't know, right? So we'll just say VA. Okay. And then what? Negative the mass of the wrench, which is 4, right? Times the velocity of the wrench, which is negative what? What is it?
20.
Negative 20. Is that what you're saying? Yeah, negative 20. Okay. So that'll be VA equals this, which is what? What is that?
80.
Yeah, 80 plus 80. It'll be plus 80. Remember, this is big. Momentum is a vector quantity, correct? A change in momentum can be a vector, correct? Yes? If I go from a certain velocity to 0, that's a change in momentum, correct? That can have a direction. If I go from 0 to a certain velocity, that's going to have a direction as well. All right, just for future reference. And then I'm going to divide by 81, correct?
Yes.
And that's plus,
Yeah.
okay? And then, well, it's not plus, it's nothing really. And then that's going to equal what? Just round it, don't go crazy, just round it. What is it? 1, yeah. It'd be 1 meter per second. Correct?
Yeah.
You okay with that? Yes? We're off.